Hey everyone, welcome to Homework 1.7a. Today we left off here, so I'm going to start just with the end piece here. I'll go over it again in class, but just so we're looking at this. So here we have what is multiplication. And this is the distributive property with multiplication. When we distribute the 3 through the parentheses. Not sure what's going on here. I think it's because it's in a table. Sorry about that. And so then the opposite is going to be division. So the best way for us to do this is to have our 3 times x plus 1 equals 9. And then we're going to start by dividing by that 3. So we'll go ahead and divide by 3. All right, and we'll end up with x plus 1 equals 3. Now what's nice about this is now I can just go ahead and we see that there's another operation here, which is addition, and so I'm going to use subtraction and subtract 1 from both sides. Now again, I know that you can do that in your head, but I do want you to show your work and be in the habit of doing that because it's going to help you in the long run. I do also want to show you that with distributive property, the other way that we could have approached this is I could go ahead and distribute the 3 through this, and therefore make it 3x plus 3 equals 9. I can then subtract 3 from both sides and get 3x equals, there we go, yep, okay, and get, oh, I did something. Oh yeah, I'm sorry. Get 3x equals 6. Sorry, I thought I copied something wrong. And so that's why it's important to show your steps. And then divide both sides by 3, and we would get x equals 2 as well. So you can do those either way. You can distribute first or divide first because this is multiplying this times this whole thing. You can go ahead and do that division of the 3 first if you like. It might save you a little bit of time. Okay? All right, so when solving an equation, there's two important key points here. If we end up with a false sentence or a false equation instead of a solution, then that means there is no answer. All right? We also end up with no solution if there is an instance that forces us to divide by 0. So if you get to a point in your equation where you have to divide by 0, right? You have 3 divided by 0, that means that it is null. There is no solution. All right. Let's take a look at the actual homework now. So in this first section, these are done correctly. And it says, explain how Miss Lee got from the first equation to the second one. For this second part, we're looking at what Mr. Snape did wrong and why the second equation does not equal the first equation. So the first was explaining what steps did Miss Lee take to get from one to the next that were legal moves, and then the second one is what did Mr. Snape do that he should not have done. All right, so I'm going to show you a couple of examples, and then I'm going to leave the rest because you all can do this. You can think through this. So for this first one, Miss Lee, I, went ahead and distributed this 4 through the parentheses. So Miss Lee distributed the 4 and multiplied 4 times 9 and negative x. Okay, so that's all you're doing is you're explaining what is the move that I took to get from this equation to this second equation. All right, I'll do one more, and then you can do the next ones by yourself. In some cases, you might say that Miss Lee did 2 steps as well, so just as a heads up. So in this one, I went from 5x equals 24 plus 2x to 3x equals 24. Well, in order to do that, I moved this 2x to the other side by subtracting it. So she subtracted 2x from both sides. Key point there, right? We have to do it to both sides in order for it to be a legal move. All right, so that's your job. You're going to go through and explain, again, what did Miss Lee do to get from equation 1 to equation 2. For this second part down here, we're looking at Mr. Snape, and he did something wrong. And so you're going to say, why did he do something wrong? So here, we have 9x equals 5x plus 4, and then Mr. Snape said, well, that is equal to 14x equals 4. Ooh, so in looking at this, it looks like Mr. Snape, instead of subtracting 5x, he subtracted 5x from the right side but added it to the left, right? So instead of subtracting it from both sides, he said, oh, minus 5x over here, got rid of the 5x over here, and then said plus 5x over here and got 14x. And that's not what we need to do. Remember, whatever we do to one side, we need to do to the other side. All right? Now, sorry about that little interruption. Okay, this second one here, we go from 1/2 x minus 8 equals 9 to x minus 8 equals 18. So here it looks like what Mr. Snape did is he went ahead and multiplied the equation by 2 so that he got rid of this 1/2. Remember that 1/2 times 2 is just going to be 1. So he got rid of that 1/2 in front of the x and then made this 9/18 by multiplying by 2. But notice that this 8 has stayed the same. So what he did wrong here is he multiplied by 2, but forgot to multiply the -8. So he didn't multiply the whole thing by 2. He needed to multiply every single piece of that equation by 2 in order for it to be a legal move. Otherwise, it won't be equivalent. And if you were to solve these, you would get 2 different answers. So that's how we know, Mr. Snape did something wrong. All right, so again, your job is for the next 3 to tell me what did Mr. Snape do incorrectly that he was not allowed to do, whereas up above, you're telling me what did I do that was correct, that was allowed to happen as a legal move to get from one equation to the next. All right, let's take a look at Noah. Noah is having trouble solving 2 equations. In each case, he took steps he thought were acceptable, but ended up with statements that are clearly not true. Analyze Noah's work on each equation and the moves he made. Were they acceptable moves? Why do you think he ended up with a false equation? So for the first one, x plus 6 equals 4x plus 1 minus 3x. Okay, and then in the next equation, it looks like he reordered these parts right here because of the commutative property, right? So it says he applied the commutative property and he kept the sign with the 3x. So far we have legal moves, right? That looks good so far. So I'm going to say yes, check. That's a legal move. For the second part then, he went ahead and combined 4x and minus 3x and came up with, very simply, x plus 1 on this side and x plus 6 on the other side. So he did combine like terms. So again, we're still good. And then he said, well, I'm going to subtract x from both sides so I can get x on one side. And what he did then is he got 6 equals 1. Well, here it looks like this equation is correct, right? And so that means that because we end up with 6 equals 1 and he made all legal moves, there is no real solution to this equation. All right, let's look at the second one. For the first one, that's our original equation. The second one, it says he applied the distributive property. So he distributed 2 times 5 is 10. 2 times x is 2x, and that's in the parentheses, so that's good. And then kept this -1. He kept that there. That looks good so far, all right? So far, we're good here. Then he went ahead and he subtracted 10 from both sides. And so when he did that, the 10 over here became 0, and the 9 over here became -1. So again, so far, we're looking good. All right, so then he said, well, I'm going to go ahead and add 1 to each side, and I'm going to get 2x equals 3x. And again, that is also true. But then he said, okay, I'm going to divide each side by x. All right, well, that is technically a legal move, right? And if you divide both sides by x, you end up with 2 equals 3. But notice that 2x equals 3x, there is a potential solution there. What solution would make both 2x and 3x equal to each other? What's the only number that we could plug in there that would make them equal to each other? So we can say he made legal moves. But what we would really want to do is, instead of applying the distributive property here, what we could do instead is we can subtract, let's say we subtract 2x from both sides, okay? Let's say we do that. And then we get 0 equals x. Ooh, now do we have an answer? Yes. So he made legal moves, but at the end, he should combine the x terms and we'll find x equals 0. Okay? And the reason for this is when we're trying to isolate that variable, we want the variable to be on one side of the equation. So instead of dividing by x, because we're solving for x, we don't want to divide by x in this situation. Instead of dividing by x, moving x to one side is going to give us a better solution. So the only possible answer for this particular situation would be that x equals 0. All right, that's it for your homework video today. Today's code word is Nike. Let's do today's code word is Nike because of our wonderful guest speaker today. All right, I hope you all have a wonderful evening, and I will see you tomorrow.